The purpose of this activity is to go through the properties for working backwards to determine the equation of an exponential function from the graph. So we're going to focus on vertical transformations, so in the form y equals a times b to the x plus k. Okay, and if we've forgotten, this k is going to shift your graph up and down, and the a is where we're going to impact reflections if there's a negative out there, and stretches and shrinks in terms of dilations. Okay, so there's a simple process to work backwards here. We're going to take advantage of some properties of exponents that we learned earlier in the year. Okay, so the first thing, step one, is to determine this value of k. That's the easiest thing to do. Remember, your exponential graph flattens out, especially the growth ones in the second column here, or second quadrant here, at y equals 0 on the basic function. And then if we have a transformation where it's a translation up or down, you're going to see that flattening out happen above or below that y equals 0. So this example 2 here, you can see that flattening out happens a few spots up compared to where it normally is. It looks like at y equals 2. And this example 3 here, you can see that flattening out happens lower. It looks like at y equals -1. Okay? So the value of k is going to be the same exact value of y wherever we flatten out at what we call there the horizontal asymptote. Okay, so the value of k is whatever the value of y is here at this spot where your graph flattens out. So that's easy to do. And as soon as we find each of these values, you're going to plug them right into the equation to keep reducing the amount of missing unknown constants. Okay, then the second step is we're going to take advantage of a property we learned earlier in algebra. Anything to the 0 power is equal to 1. Okay, so how is that helpful? Well, in this equation, our x is our exponent here. So if we can plug in a point where x equals 0, that's going to turn that part of the equation into just 1. And 1 times anything is very easy to work with. So that's the advantage of that property. Okay, so just so happens, if you remember, where x equals 0 is your y-intercept, so where your graph crosses the y-axis. Okay, so we will typically be able to see that pretty easily in most of the problems that will be given. Okay, it'll be a nice grid mark here. In this particular first graph, I wrote the numbers here in case you couldn't see them. It's at 0, 3. So we're going to plug that point in, and when x equals 0, like we said, your exponent's going to be 0 for the equation, and b to the 0 is just going to simplify to be 1. And with that, we'll be able to simplify the equation a lot further. Okay, and that will end up, you'll see in a minute, giving us the value of a in our equation. And then the third step is we're going to take advantage of the next easy point in the curve, and that's the point 1 comma something. In this particular case, it's 1, 6. Okay, and it looks like on my worksheet here, I should have made this an exponent, but b to the first power is always just equal to b. So if we plug in that point, again, it gets rid of some unknowns in the equation, so we can just narrow it down to the value of b. And once we've gone through that process, we'll be able to find our final equation. So a 3-step process, not intuitive for people doing it on their own, but it's pretty easy once you've practiced it a little bit. So we'll do this first one here together. All right. So this example 1, again, I wrote down these 2 key points. I also have this point up at the top here, 2 comma 12. We won't need it. The only reason we'll need that maybe is to check our answers at the end. Okay. But step 1 is to identify the value of y at this flattening out point, and that's just simply y equals 0 for this one. As I've said, sometimes it moves up and down, as you'll see in examples 2 and 3. But whatever that value is, that's also going to be the value of k. Okay, so step 1, k equals 0. So our equation so far is y equals a times b to the x plus 0. And going forward, we won't have to write that plus 0 because plus 0 doesn't really change your equation too much. Okay, step 2, we're going to have to actually do some math here. We're going to plug in 0, 3. I'm going to say plug in if you want. Okay, so we're going to say 3 is equal to a times b to the 0. And then again, I'm not going to write that plus 0. It doesn't seem necessary to do that. So we'll just say 3 equals a times 1, which is just simply a equals 3. Okay, and again, at the end of each step here, I'm going to rewrite the equation with the new information we have. So y equals 3 times b to the x. Okay, and I'm not going to write that plus 0 because it doesn't change anything for us. Okay, finally, step 3, we're going to plug in the point where x equals 1. So we're going to plug in 1 comma 6 in this particular case. So that'll be 6 is equal to 3 times b to the first. Okay, b to the first is just b, so 6 is equal to 3b. Divide both sides by 3, and we get b is equal to 2. Okay, so our final equation here for this first one would be y is equal to 3 parentheses 2 to the x. Okay, and again, it's plus 0 technically, but we don't have to write plus 0 or times 1 in any of our final answers. Okay, so you can practice some more of these on your own. 2 and 3 are on the handout there, so give them a try. And thanks for watching.